Okay, gonna do some board production. So I got 5 CPU boards here, so I'm just gonna go through the process of what it takes to build them. They come from a CM like this, but the CM didn't have these connectors, so I have to put them on by hand. So get our connector installed, flip it over, get one pin kind of half soldered in there, wait for that to cool, then just heat it again to get it straight, flush, because I don't have a jig for that. Then we're just gonna solder all the pins as quickly as we can. Set that aside because we have to remove the flux. I do solder these with rosin flux, so it does take some cleaning effort, which is a little annoying. Cleaning's almost the worst part. Okay. After the soldering, I need to get all this flux off, because it just looks terrible. But long term, it could also cause some corrosion. So, because it is slightly acidic, I'm going to do this over my on my bench, but I usually do it over the trash can. So, a little bit of flux remover and a toothbrush. Turn off my soldering iron. Then one of these Kim wipes, because it doesn't shred itself and leave like a lot of little paper towel fibers everywhere. Looks pretty clean. So once we have it cleaned like that, you just snap off the edges of the board, and my pliers aren't here. Hold on. Let's try that again. Okay, wrist strap on. Usually keep my tools right here so I don't waste time. So we got to break off the edges of the board because it's scored. So like that. There we go, we got one board ready to go. Set it here in the ESD safe container. Next board. Flux remover. Wipe it with the old wipe from before. It always takes more than once. And it's pretty good. So now we can break it off. Okay, now we can move on to the next step. The next step is flashing and burn-in testing. So I made this little circuit board tester, and I will show you how this works in a minute. Okay, so we're gonna start flashing the boards and testing them. So the first thing I do is put on a serial number, just so I know the order that they've been built and approximately where they end up. So we got the serial number on. So I have this tester that I made, and I'll show you what it does, but it's basically just a socket with a bunch of LEDs and resistors. So we put this in here, and then I have this hooked up to my benchtop power supply. So I connect this, and then I'm going to turn it on with like 16 volts, and then we just check that none of the LEDs are on. So we can turn that off. So now the serial adapter that is used to program the microcontroller just sticks in these pins. Turn it on. Apply a little sideways pressure so that it doesn't lose contact. Now we flash it with a special test program. So when the test program's done, you see this sequence, so I have to restart the monitoring program. So I have a monitoring application on my PC over here. So it's basically sequences slowly through every output pin. So I just make sure every output pin works by making sure that the LEDs light up in the right sequence. And every output pin is tied to an input pin, so when the output pin is driven, the input pin is checked to see if it's a 1 or a 0, and so on my monitor over here on the side, it's saying whether the input is also passing a test. So I'm visually checking the output, and it's testing its own input at the same time. And then I have a reset button here, and I can test the reset logic by like holding down this and resetting the board and verify that it comes out of the reset properly. So after we have this done, we flash the application. So now it's downloading the application. The application is pretty big. Once the application is downloaded, it takes up a lot of memory. All those web pages, stuff. So now the application is downloaded, so it has to initialize the memory, and then the application starts running. And this is what it looks like. So basically there's a lot of scanning of the inputs and the outputs. So I gotta reset it after the first time because there's some pre-initialization that happens. So now the application is running, and then the serial port just sends out the unique ID of this device for the pairing, which is what I print in that QR code. So that's basically it. So I just let it sit here for a few minutes and do this while I prepare the next board, and I just look at the current draw to make sure that it's within some tolerance of all the other boards that have been built. So while it's sitting here running like this, I will remove the serial adapter since it actually injects power into the board, and just look at the current consumption, which is around 40 milliamps while it's doing this. So it just verifies that everything seems to be within tolerance. And that's the only testing that I perform so that I can ship these out quickly, because I don't really make very much money off of these, so I can't spend a lot of time elaborately testing them and burning them in. But so far there haven't been any field failures that I am aware of. So when it's done, I'll just shut it off. Move this, take it out of the socket, and now this one will get bagged up and ready to go. Let me just show you one of the cables that I make. So this is actually a cable that can be purchased off the shelf, which makes this a lot easier because custom cables are expensive and a pain in the butt to manage. So, but with this one, I have to remove one of the wires. So I removed the appropriate wire that we don't need, where the key goes. So after I get that out, then I snap this little peg in here. It's just the key so that you can't plug it in the wrong way. And then I just write J1 because that's the connector on my board. So I write J1 on this side. So hopefully people realize that that's J1 that's written on the board. Plugs in and it's got the key way here so you can't put it in backwards.